Let's write oxidation and reduction half-reactions for this chemical process. Oxidation state of cobalt goes up. It means that cobalt is oxidized. Oxidation state of lead decreases. Lead accepts electrons and it is reduced. When we are writing oxidation half-reaction, the released electrons appear on the product side of the half-reaction. Whenever we are writing the half-reaction of reduction, we have electrons being added as a part of the reactants. They appear on the left side of the half-reaction. Notice that the 2 electrons that are lost by the cobalt are the same 2 electrons that are accepted by lead. So 2 electrons are lost, 2 electrons are received. To write oxidation and reduction half-reactions here, we first need to assign oxidation state to everything that we see in this reaction. We can see that the oxidation state of zinc is increasing, the zinc is losing electrons, it is oxidized, and our ion of hydrogen, H+1, is decreasing in oxidation state to 0, so it is accepting electrons, it has been reduced. We also can see that the chloride ion has no change in charge, so chloride ion is actually not playing an important role. It's not oxidized, neither it is reduced, so it is a spectator ion. We don't quite really need to have this entire chlorine even to be present to analyze this reaction. So I can rewrite this reaction in a simplified form, losing my spectator ion. And once again, we can see that 2 electrons are lost and 2 electrons are received. To write oxidation and reduction half-reactions, we'll once again start by assigning oxidation states to everything that we see in the reaction. Okay, we can see that oxidation state is magnesium is increasing. It means that magnesium is losing electrons, it is oxidized. Oxidation state of oxygen decreases. It means that the oxygen accepting electrons, it has been reduced. 4 electrons were lost by magnesium. 4 electrons were accepted by oxygen. It is very important. The number of electrons lost should be equal to the number of electrons that were received. In this reaction, tin gets oxidized. 2 electrons were lost. This is why charge of the tin increases by 2. And silver is getting oxidized. Its oxidation state goes down, so it accepts electrons. But judging by the charge that we observe here, the silver accepts only 1 electron to become silver atom with the oxidation state of 0. This is strange because we know that the number of electrons lost is supposed to be equal to the number of electrons that were received. And here we have a clear mismatch. This mismatch is the result of the fact that this equation is unbalanced. Silver ion accepts 1 electron and becomes silver atom. So over here we need 2 silver ions to do the job. Now I will transfer these coefficients into my overall reaction, and it will be a well-balanced equation where there is no mismatch in terms of transfer of electrons. 2 electrons has been released and 2 electrons has been accepted. Here's another example of oxidox reaction. Chromium is oxidized, lead is reduced. Chromium is losing electrons, and judging that its oxidation state went from 0 to +3, it lost 3 electrons. And lead reduced by accepting electrons. Lead used to be +2, became lead 0. It means that it accepted 2 electrons. Once again, we see mismatch between the number of electrons lost and the number of electrons received. It's a sign of unbalanced equation. So let's double the amount of chromium that is losing electrons. 2 chromium atoms would lose 6 electrons, forming 2 ions of chromium with the charge +3. Considering that each lead ion takes in 2 electrons, we would need 3 of them to accept 6 electrons total. 3 atoms of lead are formed at the end of it. Now I will transfer this coefficient coefficients into my overall equation, and I will have a nice balanced equation where there is no mismatch in terms of electrons lost and accepted. Let's look at some examples of questions about half reactions. Here's the first one. Which reaction correctly represents reduction? And the answer number one is a good one because we have iron with the charge +2 that accepts couple electrons and it is reduced to an iron with oxidation state of 0. It is element. It is atoms of iron. But in answers 2, 3, and 4, we have a strange mismatch. Look, those irons in all of those examples accept negatively charged electrons, but strangely enough, their oxidation states are rising. They are going up instead of going down. That is not supposed to be happening. Now, let's look at this question. Which equation correctly represents oxidation half reaction? Okay, looking for the answer to this question, we can safely exclude answers number 2 and number 4 because those represent acceptance of electrons, which is reduction. So now we're choosing between answers 1 and 3. And 3 is a better bet because we have 2 iodide ions. Each ion has a charge, currently has a charge of -1. It means that it has extra electron. If those extra electrons are lost by each of those 2 iodide ions, then we have 2 iodine atoms that will stick together forming a molecule of iodine, and 2 electrons will be released in the process. I don't like reaction at number 1 because I have a very strange picture. The mercury with a charge +2 releasing 2 electrons and drops in oxidation state to a 0. That's not supposed to be happening. If mercury would be with the charge +2 would be losing 2 electrons, it would become a mercury with the charge +4. So the first reaction does not make much sense. Okay, here's something is a little bit more challenging. Which equation is correctly balanced? And if we look at the first equation, we will see that we have 2 nickels losing 2 electrons each. So overall, that would be loss of 4 electrons. But if we look at what is happening to the iron, it is reduced all right, but it reduced by only 1 electron. So 4 electrons lost and 1 accepted. No, that's definitely not a correctly balanced equation. Number 2, we have nickel being oxidized and losing 2 electrons. We have iron being reduced by 1 electron, but we have 2 irons being reduced. So each of the iron with the charge +3 will accept 1 electron. 2 electrons are taken in. This seems like a good answer. 2 electrons were released and 2 electrons were accepted. This is our best choice. Let's look at the other 2 answers. Nickel being oxidized, losing 2 electrons, and our iron in the expression number 3 accepts 1 electron. Once again, mismatch between number of electrons lost and accepted, definitely not a correctly balanced reaction. The last one over here, this one is the weirdest out of them all. We have iron that is neither released nor oxidized. It has the same oxidation state on both sides. So we have nickel being oxidized, but nothing has been reduced. So as a result, this is the most incorrect equation that we can see. Now, let's pick out of these reactions the ones that is balanced correctly. So it seems like the first one is a winner because we have a bromine reacting with mercury, and mercury is clearly oxidized because it's losing 2 electrons, and bromine, 2 atoms of bromine, will be reduced. Each atom will accept 1 electron. 2 electrons lost, 2 electrons accepted. Seems like a very good match. So here's our answer. Let's look at the rest of the reactions just to see what's wrong with them. So in the reaction number 2, aluminum is reduced. It accepts 3 electrons. But look at our potassium. Our potassium only releases 1 electron. So definitely not a balanced reaction. In the number 3, we have tin that is reduced into atomic tin by accepting 4 electrons. But our hydrogen here only provides 2 electrons. So once again, we have a mismatch between number of elements that were released and between number of electrons that were released and accepted. The last one, once again, we have a problem. Magnesium is oxidized, releasing 2 electrons. Chromium is reduced by accepting 3 electrons. Mismatch in the number of electrons released and accepted. It is unbalanced equation. Here is an interesting assignment. We need to find a missing reactant in the balanced equation of half reaction. So over here we have calcium with the charge +2. That is a result of the oxidation of releasing 2 electrons. So let's fuse them together. What do we get? We get calcium, atom calcium. The calcium atom has been oxidized. And over here we have to find a missing product of the balanced equation as well. And this is a clear reaction of reduction because electrons are accepted. So what will happen to atoms of chlorine if they accept 1 electron? Each out of the couple of atoms that we have here, each will accept 1 electron. So the charge will be -1, and we will have 2 ions of chloride that have oxidation state or charge of -1.